Recent observations of 3I/Borisov have stunned astronomers, forcing a re-evaluation of everything previously understood about comets. Just 2 weeks ago, the Hubble Space Telescope captured images, revealing this interstellar visitor exhibiting behavior defying known physics. Instead of the typical cometary tail extending away from the Sun, 3I/Borisov displayed a luminous plume pointed directly towards our star, an unprecedented anti-tail phenomenon. The measurements are even more perplexing. This sunward glow is 10 times longer than it is wide, a characteristic never before observed. Conventional cometary physics offers no explanation. Solar radiation pressure should repel material away from the Sun, not attract it, yet 3I/Borisov behaves exactly counter to this expectation. This is only the beginning of the anomalies. During September's lunar eclipse, astrophotographers witnessed 3I/Borisov undergoing a dramatic color shift, turning a vibrant green practically overnight. This presents a significant problem. Spectroscopic analysis reveals a near absence of diatomic carbon, C2, the molecule responsible for green glows in comets. The source of this green hue remains a complete enigma. The James Webb Space Telescope's chemical analysis yielded results that shattered existing models of cometary composition. 3I/Borisov exhibits an astonishing 8:1 ratio of carbon dioxide to water, making it the most CO2-rich comet ever discovered, a value 6 standard deviations outside the norm. The Very Large Telescope detected pure nickel emissions, an impossibility in nature, as nickel and iron invariably occur together in cosmic processes. Further confounding the scientific community is the comet's age. Trajectory analysis suggests 3I/Borisov is over 7 billion years old, potentially predating our solar system. This ancient traveler from the galactic thick disk has journeyed through space since before Earth's existence, carrying within its structure materials and processes that predate our understanding of our cosmic neighborhood. Tonight, we delve into these inexplicable findings, exploring their implications for our understanding of interstellar objects and examining why some scientists are questioning whether these are natural phenomena or something far more extraordinary. Before we continue, please like, subscribe, and hit the notification bell if you enjoy calm, relaxing science content, perfect for unwinding or drifting off to sleep. Also, let me know where you're listening from and the current time. Some researchers propose that conventional cometary behavior under extreme conditions might explain these observations. Perhaps 3I/Borisov possesses unique ice compositions resulting in unusual sublimation patterns. Its interstellar journey may have altered its internal structure in unforeseen ways. These are reasonable scientific hypotheses, attempts to reconcile this anomaly with established knowledge. However, as more data emerges, these conventional explanations increasingly struggle to account for the evidence. The sunward glow is not an isolated anomaly. It's accompanied by a multitude of other peculiarities, painting a picture of an object unlike any encountered before. The chemical composition is anomalous. The behavior patterns are anomalous. Even the timing of its arrival seems to defy our understanding of random celestial mechanics. Eric Cateau, the Harvard astronomer who co-authored a detailed analysis of this phenomenon, stressed that the sunward extension was not a subtle effect requiring sophisticated instruments for detection. With favorable viewing conditions, it would have been a spectacular, unmistakable sight, visible to any telescope capable of resolving the object's structure. The fact that its apparent size is compressed suggests we are witnessing something truly extraordinary. Scientific consensus remains elusive. Conservative researchers maintain that unusual comet behavior, while uncommon, is not impossible considering the extreme conditions of interstellar space. 3I/Borisov has potentially traversed the galaxy for billions of years, exposed to cosmic radiation, gravitational perturbations, and thermal cycles unlike any solar system comet. Such extreme aging could indeed produce sublimation patterns resulting in unexpected optical effects. However, a growing number of scientists are raising more profound questions. If this is natural cometary behavior, why haven't we observed it in the dozens of other comets studied? Why is 3I/Borisov the first object exhibiting these characteristics? And perhaps most unsettling, why does this phenomenon appear directional? As if the object is somehow aware of and responding to the sun's position? The discovery of the anti-tail marks merely the beginning of 3I/Borisov's mysteries. As telescopes worldwide focused their attention on this interstellar visitor, each new observation unveiled further anomalies challenging our understanding of natural celestial mechanics. The object wasn't just behaving unusually, it was behaving in a manner that appeared almost purposeful, almost designed. Avi Loeb, the Harvard physicist renowned for his investigations into anomalous interstellar objects, noted that 3I/Borisov's sunward extension reminded him of similar directional phenomena expected from artificial objects. Without making definitive assertions, he highlighted that the orientation and persistence of this feature implied some form of active process, something far more complex than passive ice sublimation in response to solar heating. The enigma deepened with the analysis of the polarization characteristics of light reflected from 3I/Borisov. The object exhibited extremely deep negative polarization, minus 2.77%, with a low inversion angle, 6.41 degrees, optical properties unlike those of typical comets. This suggests either an unusual surface composition or a different class of object masquerading as a familiar celestial body. As we delve deeper into the evidence surrounding 3I/Borisov, we must confront an uncomfortable possibility. What if our assumptions about natural versus artificial objects in space are fundamentally flawed? What if the universe contains phenomena that blur the lines between geological processes and technological artifacts? The sunward glow of 3I/Borisov might be forcing us to expand our understanding of cosmic possibilities. Whether prepared or not, the data from the July Hubble observation continues to unsettle astronomers globally. Every attempt to explain the anti-tail phenomenon through conventional cometary science encounters the same obstacle. The behavior is too organized, too directional, too consistent with what we might expect from an object possessing some form of guidance system. While natural explanations cannot be definitively ruled out, neither can we ignore the mounting evidence suggesting that 3I/Borisov represents something unprecedented in our solar system. What renders this discovery even more remarkable is its connection to other anomalous behaviors observed in this mysterious visitor. The sunward glow is not an isolated anomaly, but part of a pattern of unusual characteristics seemingly defying our current understanding of interstellar object behavior. As we will discover, this anti-tail phenomenon was merely the first clue in a mystery that continues to unfold, revealing layer upon layer of inexplicable behavior that challenges everything we thought we knew about interstellar objects. The technical analysis of 3I/Borisov's anti-tail reveals details that render conventional explanations increasingly untenable. When researchers at the Harvard-Smithsonian Center for Astrophysics subjected the Hubble data to rigorous mathematical modeling, they found that the sunward extension exhibited characteristics more consistent with an active emission source than with passive reflection of solar radiation. The brightness profile didn't align with expectations for dust particles illuminated by our star, instead showing an intensity distribution suggesting internal energy sources. Martin Cordner, the astrochemist leading much of the chemical analysis of 3I/Borisov, noted that the spectroscopic signatures associated with the anti-tail region showed molecular emissions that were difficult to explain through standard sublimation processes. The wavelengths of light emitted suggested chemical reactions or energy release mechanisms not typically found in natural comet nuclei. These were not the familiar signatures of water, vapor, or carbon dioxide responding to solar heating, but something far more complex and organized. The persistence of this sunward glow presents another puzzle that challenges natural explanations. Most cometary tails are highly variable, responding to changes in solar wind intensity, the object's distance from the sun, and the composition of sublimating materials. Yet, 3I/Borisov maintained its anti-tail orientation with remarkable consistency throughout the observation period, as if guided by an internal navigation system rather than passively responding to external forces. In the weeks following the initial Hubble observation, ground-based telescopes worldwide attempted to confirm and expand upon this discovery. The Very Large Telescope in Chile, equipped with sophisticated spectrographic equipment, detected emissions from the anti-tail region showing unusual Doppler shifts. These velocity measurements suggested that material wasn't simply being pushed away from the comet's nucleus by internal pressure, but was being directed along specific trajectories with velocities inexplicable by standard outgassing models. The European Southern Observatories team, led by Dr. Thomas Puzier, found that the anti-tail emissions contained spectral lines not matching any known comet composition database. While familiar molecular signatures like cyanide and water vapor were present, they were accompanied by emission patterns suggesting more complex chemical processes. Some of these signatures resembled those created in laboratory settings under controlled conditions, raising questions about whether natural processes alone could account for their observations. Perhaps most intriguingly, the anti-tail phenomenon displayed apparent structural organization, rather than the chaotic, turbulent flow patterns typical of comet outgassing. The material extending sunward from 3I/Borisov exhibited what researchers described as laminar characteristics, flowing in organized streams that maintain their integrity over thousands of kilometers. This level of organization is virtually unknown in natural astronomical phenomena, where turbulence and chaos typically dominate the behavior of gas and dust clouds. The implications of these organized flow patterns extend beyond simple curiosity about unusual comet behavior. In terrestrial and laboratory settings, such laminar flows typically require either extremely controlled conditions or active management through electromagnetic fields or mechanical guidance systems. The possibility that 3I/Borisov might be generating such organized material streams through natural processes alone stretches the boundaries of what current physics models can accommodate. Some researchers have proposed that the interstellar environment might have altered 3I/Borisov in ways that could account for its unusual behavior. Billions of years of exposure to cosmic radiation, magnetic fields, and the extreme cold of deep space might have created internal structures or chemical compositions that respond to solar heating in unprecedented ways. This hypothesis suggests that extremely ancient objects like 3I/Borisov might represent a previously unknown class of celestial bodies shaped by processes that don't occur within individual star systems. Yet, even these exotic explanations struggle to account for the apparent directionality and persistence of the anti-tail phenomenon. If 3I/Borisov was simply responding to its unique composition and history, we might expect its behavior to be unusual but still fundamentally random. Instead, what we observe appears purposeful, as if the object is actively directing material toward our sun for reasons we cannot yet fathom. This apparent intentionality represents perhaps the most disturbing aspect of the entire mystery, suggesting that we might be witnessing behavior that transcends mere chemical and physical processes. The night of September 7th, 2025, was intended to be about the moon. Astrophotographers Gerald Raymond and Michael Jagger had positioned their equipment in the pristine darkness of Namibia's desert, preparing to capture the total lunar eclipse that would paint Earth's satellite in shades of red and copper. What they discovered instead was something that would send shockwaves through the global astronomical community and add another layer to the deepening mystery of 3I/Borisov. As the moon slipped into Earth's shadow, creating perfect dark sky conditions for deep space observation, Raymond and Jagger turned their 12-inch astrograph toward the coordinates where 3I/Borisov was racing through space at over 130,000 miles per hour. The images they captured revealed a transformation so dramatic, so unexpected, that it challenged everything scientists thought they understood about this already anomalous visitor from the stars. 3I/Borisov was glowing green, not the subtle color shifts that astronomers sometimes observe in comets as their chemical composition changes with solar heating, but a brilliant, unmistakable emerald radiance that extended across 2.5 arc-minutes of sky. The transformation was so striking that experienced astrophotographers, accustomed to the subtle beauty of celestial objects, found themselves staring at their camera screens in disbelief. This wasn't the reddish hue that spectroscopic studies had consistently detected throughout the summer of 2025. This was something entirely different, something that shouldn't have been possible. The timing of this color transformation adds yet another layer of mystery to 3I/Borisov's already inexplicable behavior. For months, every telescope that observed this interstellar visitor had recorded the same reddish coloration consistent with what astronomers might expect from an object rich in organic compounds or metallic particles reflecting sunlight. The consistency of these observations had provided at least one stable reference point in the growing catalog of 3I/Borisov anomalies. Then, overnight, that stability vanished. Dr. Kara Meach from the University of Hawaii Institute for Astronomy, who has been leading much of the coordinated observation campaign, immediately recognized the significance of this color change. In comets, green fluorescence typically results from molecules being excited by solar radiation. These carbon-based compounds, when energized by our sun's ultraviolet light, emit a characteristic green glow that has been observed in dozens of comets throughout astronomical history. It's a well-understood process, predictable and consistent with our knowledge of comet chemistry. But 3I/Borisov was supposed to be different. Spectroscopic analysis conducted by multiple telescopes throughout the summer had failed to detect significant quantities of diatomic carbon in its composition. The James Webb Space Telescope, with its unprecedented sensitivity to molecular signatures, had found the object's coma dominated by carbon dioxide, water, and carbon monoxide, but with notably low levels of the carbon compounds that typically create green cometary glows. The absence of diatomic carbon had been noted by researchers as yet another anomaly in this object's growing list of unusual characteristics. Now suddenly, 3I/Borisov was displaying the brilliant green fluorescence that should have been impossible given its observed chemistry. Either the previous spectroscopic analyses had somehow missed massive quantities of diatomic carbon, or something else was responsible for this dramatic color transformation. Both possibilities raised disturbing questions about our understanding of this visitor's true nature. Avi Loeb, the Harvard astrophysicist who has been closely monitoring 3I/Borisov since its discovery, immediately seized upon an alternative explanation for the green glow. His analysis of very large telescope data from late August had detected a dramatic surge in cyanide production from the object, with emission rates increasing exponentially as 3I/Borisov approached closer to our sun. Cyanide, while typically associated with its role as a deadly poison in terrestrial contexts, is actually one of the first molecules detected in comets as they begin active outgassing. The cyanide hypothesis offered a potentially natural explanation for the color change, but it came with its own set of troubling implications. The production rates that Loeb calculated suggested 3I/Borisov was releasing approximately 20 grams of cyanide per second at a distance of 2.85 astronomical units from the sun. This represented an almost explosively steep increase in toxic emissions as the object approached our solar system center. But even the cyanide explanation struggled to account for all aspects of the green transformation. Cyanide emissions typically produce more subtle color shifts, gradual changes that occur over weeks or months as a comet's chemistry evolves with changing solar heating. The dramatic overnight transformation observed on September 7th suggested a more sudden, more profound change in 3I/Borisov's emission characteristics. Michael Jagger, one of the astrophotographers who first captured the green transformation, noted that the color change was accompanied by other structural changes in 3I/Borisov's appearance. The object's coma had expanded significantly, now measuring 2.5 arc minutes across, and a short but distinct tail had become visible, extending away from the sun. These physical changes suggested that 3I/Borisov was entering a new phase of activity, possibly triggered by reaching some critical threshold of solar heating or internal chemical processes. The global astronomical community scrambled to understand what was happening. Telescopes from multiple continents were redirected toward 3I/Borisov, attempting to capture spectroscopic data that might explain the sudden color transformation. The European Southern Observatories, Very Large Telescope, the Gemini Observatory's twin facilities in Chile and Hawaii, and NASA's space-based assets all focused their instruments on this increasingly mysterious visitor. Initial spectroscopic analysis of the green phase revealed molecular signatures that were both familiar and deeply puzzling. While some expected compounds were present at elevated levels, the overall chemical fingerprint didn't match standard databases of comet composition during active phases. There were emission lines that suggested familiar molecules, but with intensity ratios, and Doppler characteristics that defied conventional interpretation. Dr. Christina Thomas from Northern Arizona University, who has been coordinating much of the spectroscopic analysis, described the data as unprecedented in her experience studying cometary chemistry. The molecular emissions showed evidence of complex chemical processes occurring within 3I/Borisov's coma, but the specific reactions and their energy sources remained unclear. Some of the observed signatures suggested endothermic reactions that would require external energy inputs beyond simple solar. The green glow, archival data, suggested the change might have begun several days earlier. The ATLAS survey system, which originally discovered 3I/Borisov, had been conducting routine monitoring. Observations that showed subtle color shifts beginning around September 3rd. This suggested that the transformation hadn't been sudden at all, but had evolved over several days in a way that escaped detection until optimal viewing conditions revealed its full extent. The progression from red to green over the course of those September days created an additional puzzle for researchers attempting to model 3I/Borisov's behavior. Color changes in comets typically follow predictable patterns based on distance from the sun, internal composition, and well-understood chemical processes. But the specific timing and characteristics of 3I/Borisov's transformation didn't match any known models of comet evolution. Some scientists began to question whether they were witnessing a natural process at all. The precision of the timing, the dramatic nature of the color change, and its correlation with other anomalous behaviors suggested possibilities that extended beyond conventional astronomical phenomena. Could 3I/Borisov be responding to some form of internal programming, activating different systems or processes as it reached specific points in its trajectory through our solar system? The green transformation represented more than just an interesting astronomical curiosity. It marked another step in 3I/Borisov's apparent evolution from a mysterious but potentially explicable interstellar visitor into something that challenged fundamental assumptions about what kinds of objects could exist in space. Each new discovery seemed to push this cosmic wanderer further, outside the boundaries of natural celestial mechanics in a territory where science fiction and reality began to blur in uncomfortable ways. As telescopes around the world continued their vigilant observation of 3I/Borisov, scientists found themselves confronting a possibility that many were reluctant to acknowledge openly. What if they weren't studying a comet at all, but something far more complex, something designed to mimic natural astronomical phenomena while pursuing its own mysterious agenda? The green transformation had provided another piece of evidence supporting this disturbing hypothesis. Another indication that 3I/Borisov might represent humanity's first encounter with technology from beyond our solar system. The implications of this color transformation extended far beyond academic curiosity about unusual comet chemistry. If 3I/Borisov was indeed artificial in origin, then the green glow might represent some form of activation sequence, a system coming online as the object approached critical distances from our sun. The timing correlation between the color change and the object's trajectory suggested a level of sophistication that would dwarf any technology currently possessed by human civilization. Alternative theories emerged as researchers struggled to explain the phenomenon through natural processes. Some proposed that 3I/Borisov contained exotic ice compositions created during its billions of years wandering through interstellar space. The extreme cold and radiation environment between stars might have produced chemical compounds unknown in our solar system, materials that could fluoresce in unexpected ways when heated by solar radiation. Yet, even these exotic chemistry hypotheses faced significant challenges when confronted with the observational data. The sudden nature of the transformation, its correlation with other anomalous behaviors, and the specific wavelengths of light being emitted, all suggested processes more organized than random chemical reactions. The green glow appeared to be structured, controlled, almost purposeful in its intensity and distribution across 3I/Borisov's expanding coma. Dr. Michelle Bannister from the University of Canterbury, who had been modeling 3I/Borisov's likely composition based on its presumed origins in the galaxy's thick disk, found that her predictions couldn't account for the observed color transformation. Objects formed around ancient stars should contain primarily water ice and simple organic compounds, materials that wouldn't produce the dramatic fluorescence now being observed. The chemistry required for such brilliant green emissions suggested formation conditions or processing mechanisms that didn't exist in the early galaxy. The mystery reached new depths when researchers noticed that the green glow wasn't uniformly distributed across 3I/Borisov's coma. High-resolution images revealed patterns within the emission, structured regions where the intensity varied in ways that resembled technological displays more than natural atmospheric phenomena. These patterns changed subtly over time, suggesting dynamic processes occurring within the object's envelope of gas and dust. Perhaps most unsettling was the discovery that 3I/Borisov's green transformation had been accompanied by changes in its radio emissions. Deep space monitoring stations detected subtle alterations in the electromagnetic signature emanating from the object's vicinity, frequency shifts that couldn't be explained by natural plasma interactions or solar wind effects. While these radio variations remained within the range that might be produced by unusual but natural processes, their timing correlation with the visual color change suggested coordinated phenomena occurring across multiple wavelengths of the electromagnetic spectrum. The green mystery of 3I/Borisov had transformed from an interesting astronomical anomaly into a catalyst for fundamental questions about the nature of objects that traverse interstellar space. Each attempt to explain the phenomenon through conventional science revealed new layers of complexity, new evidence that this visitor from the stars operated according to principles that challenged our understanding of what was possible in the universe. As the object continued its relentless approach toward our sun, scientists realized they were no longer simply observing a comet, but potentially witnessing the activation of something far more extraordinary and possibly dangerous than anything they had prepared to encounter. On July 16th, 2025, just 2 weeks after 3I/Borisov was first detected racing through our solar system, Harvard physicist Avi Loeb published a paper that would ignite the most explosive scientific controversy of the decade. The document, co-authored with Adam Hibbard and Adam CRA from the Initiative for Interstellar Studies, carried a title that seemed more suited to science fiction than peer-reviewed astronomy. Is the interstellar object 3I/Borisov alien technology? The paper's central hypothesis was as audacious as it was terrifying. Loeb and his colleagues argued that 3I/Borisov might not be a natural comet at all, but rather an artificial probe sent by an extraterrestrial civilization, possibly with hostile intentions toward Earth. This wasn't mere speculation or attention-seeking sensationalism. The researchers had conducted rigorous mathematical analysis of the object's trajectory, timing, and physical characteristics, building a case that challenged the astronomical community's fundamental assumptions about what kinds of objects. The possibility that 3IAtlas, an interstellar object, could be of artificial origin continued to dominate scientific discourse. Lowe's argument that the timing of its arrival was statistically improbable bordering on impossible was bolstered by its trajectory, which aligned precisely with the ecliptic plane, the imaginary disk encompassing most planetary orbits around our sun. The probability of a random interstellar object following this path was infinitesimally small, less than 0.2%. Even more unsettling was its approach angle, which would allow for close observation of Venus, Mars, and Jupiter, an ideal path for a reconnaissance mission targeting potentially habitable worlds. However, the most disturbing aspect of Lowe's hypothesis revolved around 3IAtlas's projected perihelion timing. Its closest approach to the Sun, on October 30th, 2025, would place it on the opposite side of the Sun from Earth, effectively shielding it from detailed, ground-based observation, precisely when it would be brightest and most active. This strategic positioning suggested a deliberate attempt at covert observation. Lowe's analysis indicated this hidden perihelion period would be perfect for a reverse solar orbit maneuver, an advanced propulsion technique leveraging a star's gravity and a spacecraft's thrust for dramatic velocity changes with minimal energy expenditure. If 3IAtlas were artificial, this maneuver could alter its hyperbolic trajectory, binding it to our solar system and potentially setting it on a course for Earth intercept as early as November or December 2025. Lowe's investigation extended beyond trajectory analysis. He highlighted physical anomalies inconsistent with natural comet formation. 3IAtlas's brightness fluctuations suggested either an unusually large nucleus for an interstellar object or an artificial structure designed to mimic a comet. The absence of a prominent dust tail in early observations further supported the artificial hypothesis, as natural comets typically begin outgassing at far greater distances from the Sun. The scientific community's response to Lowe's paper was immediate and overwhelmingly negative. Colleagues, once respectful of his contributions to theoretical astrophysics, accused him of sacrificing scientific rigor for publicity. Dr. Chris Lintott from Oxford University, involved in studying 3IAtlas's galactic origins, dismissed the alien spacecraft theory as baseless speculation, deeming it detrimental to legitimate scientific research. The criticism transcended mere academic disagreement. Many astronomers argued Lowe's hypothesis was actively harmful to public understanding of science, fueling conspiracy theories and eroding confidence in evidence-based research. The controversy spread rapidly across social media, academic conferences, and popular science publications, creating a rift within the astronomical community unprecedented since the Pluto planet debates. Undeterred by the intense backlash, Lowe maintained that extraordinary claims warrant extraordinary investigation, not immediate dismissal. He accused his critics of willful ignorance, a refusal to consider possibilities that challenged established assumptions about humanity's place in the universe. He insisted the scientific method demands evaluation of all testable hypotheses based on evidence, regardless of potentially unsettling implications. Unexpected support for the alien probe hypothesis emerged from 3IAtlas's observed entry point into our solar system. Approaching from the direction of Sagittarius, where the galactic center resides, suggested origins from the galactic thick disk, a region containing ancient stars and potentially ancient civilizations. If artificial, 3IAtlas might represent technology from a species that achieved interstellar travel billions of years before Earth's existence. Further bolstering Lowe's theory was his analysis of 3IAtlas's velocity. Traveling at approximately 60 kilometers per second relative to our Sun, significantly faster than typical interstellar objects, suggested either formation around a very massive star or artificial acceleration beyond what natural gravitational slingshot effects could achieve. This speed, coupled with a calculated departure point from the inner Oort cloud, approximately 80 years prior, coincided precisely with the advent of human radio technology. The timing correlation between Earth's first radio broadcasts and 3IAtlas's calculated departure sent shivers down the spines of researchers seriously considering Lowe's hypothesis. An alien civilization monitoring our galaxy for signs of technological development would have detected these radio emissions in the 1940s, providing the first clear evidence of intelligence on Earth. A probe launched in response would arrive precisely when 3IAtlas appeared. Lowe delved into even more unsettling possibilities. If 3IAtlas were an alien probe, its intentions remained unknown. While it could represent peaceful scientific exploration, Lowe warned it might embody the dark forest hypothesis, a concept suggesting the universe is populated by predatory civilizations, eliminating potential competitors before they become threats. 3IAtlas's cautious trajectory, hidden perihelion approach, and sophisticated camouflage as a natural comet could all support such a sinister mission. Lowe argued that even with a low probability, the potential consequences were so catastrophic as to demand serious consideration and preparation. His warnings extended beyond academic speculation into practical recommendations for planetary defense. He urged immediate interception missions before 3IAtlas's perihelion passage, arguing humanity might have mere months to determine its true nature before potentially hostile capabilities were revealed. The immense technical challenges of such a mission would demand unprecedented international cooperation and resource commitment, but Lowe maintained the stakes justified extraordinary measures. Critics condemned these recommendations as irresponsible fear-mongering, but Lowe countered with Pascal's wager. The potential benefits of being prepared far outweighed the costs of being wrong. The controversy intensified as Lowe faced death threats from conspiracy theorists accusing him of government cover-up and professional ostracization from colleagues who viewed his hypothesis as career-destroying pseudoscience. Caught in this maelstrom, he found himself defending both his scientific approach and his personal safety as the debate escalated beyond academic boundaries. Media coverage transformed 3IAtlas from an astronomical curiosity into a global phenomenon. Cable news networks aired heated debates between Lowe and his critics, while internet forums exploded with speculation about alien visitation and government conspiracies. The scientific dispute became a cultural battleground, pitting evidence-based reasoning against emotional reactions and preconceived notions. Despite the sensationalism and personal attacks, Lowe's core argument remained mathematically sound and observationally grounded. While his conclusions might be incorrect, his methodology adhered to established scientific principles of hypothesis formation and testing. The hostile reaction from much of the astronomical community revealed as much about the sociology of Science as about the merits of the alien probe theory. As 3IAtlas relentlessly approached the sun, carrying the potential to reshape humanity's understanding of its place in the universe. Lowe's controversial hypothesis served as a stark reminder that the cosmos might hold realities far stranger and more dangerous than our most conservative models can accommodate. Regardless of his ultimate vindication or discrediting, his willingness to voice the unthinkable forever altered humanity's perception of interstellar visitors. The aftermath of Lowe's paper exposed deep divisions within the scientific establishment regarding the handling of potentially paradigm-shifting discoveries. Traditional peer review processes designed for incremental advancements proved inadequate for evaluating claims challenging fundamental assumptions about reality. The 3IAtlas controversy highlighted the tension between scientific conservatism necessary for maintaining credibility and the intellectual courage required to investigate truly revolutionary possibilities. International space agencies found themselves in an impossible position. Publicly maintaining 3IAtlas appeared to be a natural comet while privately circulating classified briefings among defense establishments exploring worst-case scenarios and potential responses. The gap between public reassurance and private concern reflected the unprecedented challenge of managing a situation where scientific uncertainty intersected with existential security implications. Lowe's hypothesis gained unexpected support when independent researchers identified further anomalies in 3IAtlas's behavior supporting artificial origin theories. Radio emissions, initially dismissed as natural plasma interactions, showed subtle modulation patterns resembling compressed data transmissions. While these signals could theoretically result from natural processes, their mathematical structure exhibited properties more consistent with information encoding than random electromagnetic noise. Lowe's prediction of 3IAtlas's hidden perihelion maneuver created a countdown atmosphere throughout the summer of 2025. If he was correct, October would bring either confirmation through observable propulsive maneuvers or its refutation through continued natural comet behavior. The binary nature of this test case made the controversy particularly acute. No middle ground existed for compromise or reinterpretation. Government responses to Lowe's warnings varied across international borders. Some nations quietly enhanced space surveillance and updated planetary defense protocols, while others publicly ridiculed the alien probe hypothesis. This patchwork of official reactions reflected deeper uncertainties about how humanity should respond to potentially transformative scenarios, even theoretical ones. The controversy peaked when Lowe challenged his critics to propose alternative explanations for 3IAtlas's accumulating anomalies. The anti-tail phenomenon, chemical composition irregularities, trajectory precision, and timing correlations presented a puzzle that natural comet models struggled to address comprehensively. While individual anomalies might be explicable through exotic natural processes, their convergence in a single object stretched probability beyond acceptable limits. Most significantly, Lowe's hypothesis transformed 3IAtlas from an object of purely academic interest into a potential catalyst for species-level decision-making. Whether the theory proved correct or not, it forced humanity to confront fundamental questions about its preparedness for contact with non-human intelligence and its ability to distinguish between natural and artificial phenomena in a universe filled with possibilities beyond current scientific understanding. The scientific method itself seemed on trial alongside 3IAtlas, tested by circumstances its founders could never have anticipated. As the mysterious visitor from the stars continued its approach toward the hidden side of our sun, carrying secrets that might reshape human civilization or reveal nothing more than the exotic behavior of ancient cosmic ice, Lowe's controversial hypothesis served as both a warning and an invitation to expand the boundaries of scientific inquiry and human discovery. On August 23, 2025, Dr. Thomas Puzia and his team at the Pontifical Catholic University of Chile made a discovery that would shatter fundamental assumptions about cosmic chemistry and add another piece to the growing puzzle of 3IAtlas's true nature. Using the European Southern Observatory's Very Large Telescope, equipped with state-of-the-art spectrographic instruments, they detected something impossible in nature: pure nickel emissions streaming from 3IAtlas, completely unaccompanied by iron. In every known natural process throughout the universe, from stellar nucleosynthesis to planetary core formation, nickel and iron are inseparable cosmic twins, forged simultaneously in the hearts of massive stars, dispersed together in supernova explosions, and found paired in virtually every astronomical object where metals have been detected. Their universal pairing represents one of the most fundamental constants in cosmic chemistry, a relationship so reliable that astronomers use iron-to-nickel ratios as standard markers for determining the origin and evolution of celestial objects. Yet, 3IAtlas was producing nickel emissions with no detectable iron signatures whatsoever. The spectroscopic data from the Very Large Telescope showed clear, unmistakable absorption and emission lines at wavelengths characteristic of nickel atoms, but the iron lines that should have accompanied them were completely absent. This wasn't a matter of detection sensitivity or instrumental limitations. The telescopes were easily capable of detecting iron at the concentrations that should have been present if natural processes were responsible for the nickel emissions. Dr. Puzia, a veteran astronomer who had spent decades studying the chemical composition of stellar objects, described the discovery as unprecedented. Natural cosmic processes simply do not produce isolated nickel in the quantities being observed from 3IAtlas. The energy requirements for separating nickel from iron in space environments exceed what any known stellar or interstellar mechanism could provide. What they were observing suggested industrial-scale chemical processing of a sophistication surpassing current human technological capabilities. The implications were staggering. On Earth, producing pure nickel requires advanced metallurgical techniques involving high-temperature furnaces, chemical solvents, or electromagnetic separation processes, industrial methods designed specifically to overcome the natural tendency of nickel and iron to remain chemically bonded. The fact that 3IAtlas was somehow generating pure nickel emissions implied either unknown natural processes operating under extreme conditions or artificial systems capable of sophisticated materials processing. The Very Large Telescope observations revealed additional disturbing details about 3IAtlas's nickel emissions. The spectral signatures showed Doppler shifts indicating that nickel-bearing material was being ejected from the object at velocities inexplicable by standard outgassing models. Natural sublimation of comet ices produces gas velocities of a few hundred m/s at most. The nickel emissions from 3IAtlas showed velocity distributions suggesting directed ejection at several km/s, consistent with active propulsion or controlled material processing rather than passive thermal effects. Even more puzzling was the temporal behavior of the nickel emissions. Rather than a gradual, steady increase expected as a comet approaches the Sun and experiences increasing thermal input, 3IAtlas's nickel production showed dramatic spikes and variations seemingly unrelated to its distance from our star. The emission rates followed a complex mathematical relationship, increasing proportionally to the object's heliocentric distance raised to approximately the -10th power. This extremely steep dependence suggested internal processes governed by feedback mechanisms rather than simple thermal chemistry. Dr. Martin Cordner from NASA's Goddard Space Flight Center, who had been coordinating spectroscopic observations across multiple telescopes, confirmed that the nickel without iron phenomenon extended across all wavelengths of observation. Infrared, visible light, and radio telescope data all showed consistent evidence of nickel processing without corresponding iron signatures. This multi-wavelength confirmation eliminated the possibility that the observations resulted from instrumental artifacts or atmospheric interference effects. The discovery prompted frantic searches through astronomical databases to find any precedent for isolated nickel emissions in cosmic objects. Researchers examined spectroscopic data from thousands of comets, asteroids, stellar atmospheres, and interstellar gas clouds, looking for any natural phenomenon that might explain what they were observing in 3IAtlas. The search proved fruitless. In the entire catalog of astronomical spectroscopy spanning over a century of observations, no natural object had ever been found producing significant nickel emissions without accompanying iron signatures. The industrial implications of pure nickel production were not lost on material scientists who became involved in analyzing the 3IAtlas data. Dr. Sarah Johnson, a metallurgical engineer at MIT, noted that the processes required to separate nickel from iron represent some of humanity's most advanced manufacturing techniques. These methods require precise control of temperature, pressure, and chemical environments, along with a sophisticated understanding of molecular bonding and atomic behavior. The idea that such processes might be occurring naturally in a comet nucleus challenged everything known about both cosmic chemistry and material science. Alternative explanations emerged as researchers struggled to fit the nickel anomaly into natural frameworks. Some proposed that 3IAtlas might contain exotic materials created during its billions of years wandering through interstellar space. Cosmic ray bombardment, extreme temperature cycling, and exposure to interstellar magnetic fields might have produced unusual chemical separations unknown in solar system objects. While these conditions could theoretically create novel materials, the energy requirements for large-scale nickel-iron separation still exceeded what any known interstellar process could provide. The timing of the nickel emissions discovery coincided with other anomalous chemical signatures being detected from 3IAtlas. The same very large telescope observations that revealed the isolated nickel also showed unusual molecular emission patterns that didn't match standard comet chemistry databases. Complex organic compounds appeared to be forming and dissociating in the object's coma at rates and in combinations that suggested catalytic processes rather than simple thermal decomposition. Perhaps most unsettling was the discovery that the nickel emissions showed evidence of isotopic fractionation patterns characteristic of industrial refining rather than natural cosmic abundances. Different isotopes of nickel were being produced in ratios that matched those found in terrestrial manufacturing processes, particularly electroplating and aerospace alloy production. Natural stellar nucleosynthesis produces nickel isotopes in well-established ratios that serve as cosmic fingerprints for natural versus artificial origin. 3IAtlas's nickel showed isotopic signatures more consistent with advanced technological processing than stellar formation. The industrial metallurgy hypothesis gained further support when researchers noticed that the nickel emission spectra included trace signatures of other elements commonly used in high-performance alloys. Chromium, molybdenum, and cobalt appeared in the same spectral regions where the isolated nickel was most prominent, creating emission patterns remarkably similar to those produced by aerospace-grade superalloys. These materials represent the pinnacle of human metallurgical achievement, designed for extreme temperature and stress applications in jet engines and spacecraft components. Dr. Elena Rodriguez, a spectrochemist at the European Southern Observatory who had been analyzing the detailed emission line profiles, made an even more disturbing discovery. The nickel emissions from 3IAtlas showed subtle but consistent frequency modulations that resembled the acoustic signatures of mechanical processing equipment. While the modulations remained within ranges that might result from turbulent gas dynamics, the mathematical structure exhibited harmonic relationships characteristic of rotating machinery or precision manufacturing tools. The possibility that 3IAtlas might be conducting active materials processing operations sent shock waves through both the astronomical and defense communities. If the object was indeed artificial, Its demonstrated ability to refine metals and manufacture advanced alloys suggested technological capabilities far beyond what had been attributed to any hypothetical alien civilization. Such capabilities would represent not just scientific advancement, but potential military applications that could render human defense systems obsolete. Government classified briefings began, incorporating the nickel separation data into threat assessment models, exploring scenarios where 3IAtlas might be manufacturing components for unknown purposes during its passage through our solar system. The object's trajectory, which would bring it close to multiple planets, suddenly took on more sinister implications if it was actively producing materials that could be used for weapons, surveillance equipment, or self-replication systems. The scientific community found itself divided not only about the implications of the nickel anomaly, but also about how to investigate it. Further, some researchers argued for immediate spacecraft missions to collect direct samples from 3IAtlas's coma, hoping to determine definitively whether the observed emissions resulted from natural or artificial processes. Others warned that approaching an object capable of such sophisticated chemistry might pose unacceptable risks to human personnel and equipment. As 3IAtlas continued its approach toward the sun, its nickel without iron emissions served as a constant reminder that this visitor from the stars operated according to principles that challenged humanity's understanding of what was possible in the cosmos. Whether the phenomenon would eventually be explained through exotic natural processes or confirmed as evidence of advanced alien technology, it had already transformed 3IAtlas from an astronomical curiosity into a potential harbinger of technologies beyond current human comprehension. The metallurgical mystery deepened when follow-up observations revealed that the nickel emissions weren't random, but followed precise geometric patterns within 3IAtlas's expanding coma. High-resolution spectroscopic mapping showed that the pure nickel was being distributed along specific trajectories, creating what appeared to be structured formations within the gas and dust envelopes surrounding the object. These patterns resembled the controlled material flows seen in advanced manufacturing processes rather than the chaotic turbulence expected from natural outgassing phenomena. Dr. James Patterson, a materials scientist from Caltech who specialized in zero-gravity manufacturing processes, analyzed the spatial distribution data and found correlations that defied natural explanation. The nickel-bearing stream showed laminar flow characteristics that could only be maintained through active field control or mechanical guidance systems. In terrestrial manufacturing, similar flow patterns require sophisticated electromagnetic containment systems or precision mechanical channeling. The possibility that 3IAtlas possessed such capabilities suggested technological sophistication exceeding anything in human industrial arsenals. The pure nickel phenomenon took on additional significance when researchers discovered that the emission rates correlated with the object's rotational period. As 3IAtlas spun through space, the intensity of nickel emissions varied in a regular cycle that suggested the processing systems were concentrated in specific regions of the object structure. This rotational modulation implied internal architecture with dedicated manufacturing zones, further supporting theories that 3IAtlas might be an artificial construct disguised as a natural comet. International materials research laboratories began conducting experiments to determine whether any known natural process could produce the nickel separation effects observed in 3IAtlas. Teams in Japan, Germany, and the United States subjected various cosmic ice analogs to extreme conditions simulating interstellar space environments, testing whether cosmic ray bombardment, magnetic field interactions, or thermal cycling could create the observed chemical fractionation. Despite months of intensive experimentation, no natural process was found capable of producing pure nickel emissions at the scales and purities being observed from the interstellar visitor. The failure to reproduce the nickel separation phenomenon through natural means led to increasingly exotic theoretical proposals. Some physicists suggested that 3IAtlas might have encountered a magnetar during its interstellar journey, exposing it to magnetic fields trillions of times stronger than Earth's. Under such extreme conditions, electromagnetic forces might overcome chemical bonding in ways that could separate nickel from iron at the atomic level. However, calculations showed that objects exposed to magnetar-level magnetic fields would be completely disrupted, not merely chemically altered. More disturbing was the discovery that 3IAtlas's nickel emissions included trace quantities of isotopes that didn't occur naturally in cosmic abundance ratios. Nickel 58 and nickel 60 appeared in concentrations suggesting artificial enrichment processes, while other isotopes were depleted below natural cosmic levels. This isotopic fingerprint matched patterns seen in terrestrial nuclear reactors and particle accelerators, technologies requiring precise control of atomic processes at energies far beyond what natural cosmic environments could provide. The implications for planetary defense became increasingly urgent as analysts realized that any civilization capable of the observed metallurgical processes would possess technological capabilities that could render conventional military responses obsolete. Pure nickel production required not just advanced chemistry, but also sophisticated energy sources, precision control systems, and manufacturing infrastructure, suggesting a technological base millions of years ahead of human development. If 3IAtlas was indeed artificial, humanity was potentially facing contact with a civilization whose capabilities bordered on the godlike. Government response teams began developing contingency protocols for scenarios where 3IAtlas might reveal overtly artificial capabilities during its approach. October 30th, 2025. This date, circled on astronomical calendars worldwide since 3.2. Atlas's discovery marked the object's perihelion, its closest approach to the Sun. However, as this crucial date loomed, a disturbing realization gripped the global scientific community. During 3.2 most active phase, when it would be brightest, it would be completely obscured from Earth-based observation, hidden directly behind the Sun's blinding disk. The timing was suspiciously convenient for an object attempting to conceal its activities. The Sun's overwhelming brightness and its position in the sky created a natural blind spot, rendering every ground-based telescope on Earth useless during the weeks surrounding perihelion. Space-based observatories like Hubble and the James Webb Space Telescope faced similar limitations, pointing their sensitive instruments near the Sun risked permanent damage. Dr. Marco Marcelli of the European Space Agency's Near-Earth Object Coordination Center had been tracking 3.2 trajectory with mounting unease. The precision required for an interstellar object to arrive at our solar system and achieve such perfect concealment during its most active phase defied statistical probability. Billions of years of interstellar travel, subject to random gravitational perturbations, should have scattered any artificial timing by vast margins. Yet, 3.2 would spend its perihelion passage in what Marcelli described as the ideal hiding place for covert operations. Avi Loeb, who had been warning about 3.2 potentially artificial nature since July, immediately grasped the strategic implications. In his analysis of the hidden perihelion scenario, Loeb calculated that this positioning would provide ideal conditions for a reverse solar orbit maneuver, an advanced aerospace technique allowing a spacecraft to dramatically alter its trajectory while remaining undetected from Earth. If the object were an alien probe, this hidden window could allow it to transition from a hyperbolic path to a stable orbit within our solar system, potentially setting the stage for an Earth intercept. The physics of a reverse solar orbit maneuver are well understood by spacecraft engineers, but have never been observed in any natural astronomical object. The technique requires a precise combination of gravitational acceleration from the Sun and precisely timed propulsive burns to achieve velocity changes impossible through gravity or thrust alone. For 3.2 Such a maneuver could decelerate the object from escape velocity to orbital speed, positioning it for a potential Earth intercept in the months following perihelion. Mission planners at NASA and other space agencies were confronted with an unprecedented situation. The most significant astronomical event in human history might be unfolding behind the sun, completely invisible to direct observation. Traditional methods for studying comets during perihelion involved intensive monitoring as solar heating triggered maximum outgassing and tail development. For 3IAtlas, this critical phase would remain shrouded in secrecy, hidden by the very star driving its behavior. The Parker Solar Probe, humanity's fastest and most heat-resistant spacecraft, offered the only chance for direct observation during 3IAtlas's hidden perihelion passage. Launched in 2018 to study the sun's corona, Parker was equipped to withstand the extreme thermal environment near our star. Mission controllers calculated the probe might be positioned to observe 3.2, both reassuring and deeply unsettling. The spacecraft confirmed that 3IAtlas was approaching perihelion along its predicted trajectory, ruling out any dramatic course changes suggesting immediate hostile intent. However, the probe's instruments also detected unprecedented levels of electromagnetic activity emanating from the object, including radio emissions with complex modulation patterns, inconsistent with natural plasma interactions. Dr. Nicola Fox, director of NASA's Heliophysics Division, reviewed the Parker data with growing concern. The electromagnetic signatures from 3IAtlas included frequency bands typically associated with communication systems and data transmission protocols. While natural phenomena could theoretically produce similar signals, the mathematical structure of the emissions showed characteristics more consistent with artificial information encoding than random electromagnetic noise. The probe was essentially detecting what appeared to be radio chatter from what was assumed to be an inert chunk of cosmic ice. The European Space Agency's Solar Orbiter mission provided additional observations as 3IAtlas approached its hidden perihelion. Unlike Parker Solar Probe, which followed an elliptical path bringing it periodically close to the Sun, Solar Orbiter maintained a more distant but stable observing position, enabling continuous monitoring of the inner solar system. The spacecraft's instruments detected gravitational anomalies near 3IAtlas, suggesting its mass distribution was changing as it approached perihelion. These mass redistribution effects implied significant structural modifications as the object neared the Sun. Natural comets experience mass loss during perihelion as solar heating sublimate surface ices, but the gravitational signatures from 3IAtlas suggested mass was being moved, not lost. The patterns resembled what aerospace engineers would expect from a spacecraft reconfiguring its internal systems or deploying previously concealed structures. Ground-based radio telescopes, while unable to directly observe 3IAtlas during its hidden passage, could monitor the electromagnetic environment around the Sun for unusual activity. The Very Large Array in New Mexico and the Arecibo Observatory in Puerto Rico detected subtle but persistent radio anomalies emanating from 3IAtlas's predicted position behind the Sun. These signals showed Doppler characteristics consistent with an object following the expected trajectory, but with modulation patterns defying natural explanation. The radio observations revealed another disturbing aspect of 3IAtlas's hidden perihelion passage. The electromagnetic emissions weren't constant, but showed periodic variations, correlating with the object's rotational period. As 3IAtlas spun behind the Sun, its radio signature pulsed rhythmically, suggesting the emissions originated from specific locations on or within the object's structure. Natural electromagnetic phenomena typically exhibit random or gradually varying intensities, not the precise periodic behavior observed. Dr. Seth Shostak from the SETI Institute became involved in analyzing 3IAtlas's radio emissions, bringing decades of experience in searching for artificial signals from extraterrestrial civilizations. His initial assessment was that the signals fell within parameters that could theoretically result from natural processes, but he acknowledged that their mathematical structure showed characteristics long theorized by SETI researchers as potentially indicating a technological origin. The emissions from 3IAtlas represented the closest thing to a confirmed artificial signal the SETI community had ever encountered. The hidden perihelion scenario took on ominous implications when orbital mechanics specialists calculated 3IAtlas's potential trajectories after its passage behind the Sun. If the object performed a reverse solar Oberth maneuver during its concealed period, it could emerge from behind the Sun on a course toward Earth, arriving as early as late November or early December 2025. The calculations showed such a trajectory was energetically feasible using known propulsion physics, requiring thrust capabilities within the range of what advanced spacecraft might possess. International space agencies began coordinating unprecedented observation campaigns for the moment 3IAtlas would re-emerge from behind the Sun in early December. Every available telescope and spacecraft would be focused on the expected emergence point, ready to detect any changes in the object's trajectory, velocity, or physical characteristics. This represented the largest coordinated astronomical effort in history, mobilizing resources across national boundaries and institutional rivalries. Military strategists quietly developed contingency plans for scenarios where 3IAtlas might emerge on an Earth intercept trajectory. While publicly maintaining such scenarios were highly speculative, classified briefings explored response options ranging from communication attempts to kinetic interception missions. The hidden perihelion period had transformed from an astronomical inconvenience into a potential countdown to the most significant event in human history. As October 30th approached and 3IAtlas disappeared behind the Sun's blinding disk, humanity faced its first experience of cosmic uncertainty since the dawn of civilization. For the first time in history, an object with potentially decisive implications for human survival was operating beyond direct observation, hidden in the one place in the solar system where Earth-based monitoring was impossible. The next 6 weeks would determine whether 3IAtlas would emerge as a confirmed natural comet or reveal itself as something far more extraordinary and potentially dangerous. The hidden perihelion passage of 3IAtlas had created an information vacuum at the worst possible time, forcing humanity to confront the possibility that its first contact with extraterrestrial intelligence might be occurring in complete secrecy behind the very star that had given birth to life on Earth. As the object vanished into the Sun's glare, carrying with it the potential to transform human understanding of its place in the universe, the waiting began. On August 6, 2025, the James Webb Space Telescope achieved the seemingly impossible, capturing detailed spectroscopic data from an interstellar visitor traveling at over 130,000 miles per hour through our solar system. When the results from Webb's near-infrared spectrograph arrived at NASA's Goddard Space Flight Center, they revealed a chemical composition so bizarre, so fundamentally unlike anything previously known, that astronomers were forced to question everything they thought they knew about comet formation and interstellar chemistry. 3IAtlas was not behaving like a comet at all. Instead of the water-rich composition defining these ancient remnants of planetary formation, Webb's instruments detected a coma dominated by carbon dioxide at concentrations defying every model of natural comet chemistry. The object was releasing carbon dioxide at an 8-to-1 ratio compared to water vapor, making it the most CO2-rich comet ever observed and placing it 6 standard deviations beyond typical cometary values. Dr. Martin Cordner from NASA's Goddard Space Flight Center, who led the Webb observation team, described the discovery as unprecedented in decades of comet spectroscopy. Natural comets form in the cold outer regions of star systems where water ice dominates the available frozen materials. Carbon dioxide, while present in small quantities, never approaches the concentrations observed in 3IAtlas. The object appeared to have formed under conditions unlike any known in planetary system formation models. The chemical anomaly extended beyond simple abundance ratios to include molecular signatures, challenging the fundamental understanding of how matter behaves in space environments. Webb's spectrograph detected carbonyl sulfide in 3IAtlas's coma, a compound requiring specific temperature and pressure conditions to form. The presence of this molecule suggested either formation environments unlike any known natural process or active chemical synthesis occurring within the object's nucleus. Even more disturbing was the isotopic composition of the carbon dioxide emissions. Natural cosmic processes produce carbon isotopes in well-established ratios that serve as fingerprints for stellar nuclear synthesis and planetary formation. The carbon dioxide streaming from 3IAtlas showed isotopic fractionation patterns that didn't match any known natural source. The ratios resembled those produced in industrial chemical plants where carbon compounds are processed under controlled conditions for manufacturing purposes. The water signatures detected by Webb provided further evidence that 3IAtlas operated according to non-natural principles. While water vapor was present in the object's coma, it appeared in forms and at temperatures suggesting active processing rather than simple sublimation of surface ices. Infrared analysis revealed water molecules with rotational and vibrational energy states indicating recent formation through chemical reactions, rather than phase transitions from solid to gas. Dr. Cyril Opatom from the University of Edinburgh, specializing in cometary chemistry analysis, noted that the Webb data showed molecular emission patterns characteristic of catalytic processes. The relative abundances of different molecular species in their energy states suggested that chemical reactions were being actively driven within 3IAtlas's nucleus, possibly through artificial catalysts or energy sources. Natural comet outgassing typically shows the random molecular distributions expected from thermal sublimation, not the organized chemical signatures being observed. The carbon monoxide detected in 3IAtlas's spectrum presented another puzzle challenging natural formation theories. While CO commonly appears in comet spectra, the quantities and distribution patterns from 3IAtlas suggested production through carbon dioxide dissociation, rather than direct sublimation from frozen reserves. This indicated that the object possessed internal energy sources, capable of driving endothermic chemical reactions requiring more energy input than solar heating alone could provide. Temperature measurements from Webb's infrared sensors revealed thermal anomalies, supporting theories of active internal processes within 3IAtlas. The object's nucleus showed hot spots that couldn't be explained by solar heating patterns alone. These thermal signatures suggested localized energy sources distributed throughout the object structure, creating temperature gradients more consistent with powered systems than passive thermal responses to solar radiation. The spectroscopic data also revealed trace quantities of complex organic molecules that shouldn't have survived billions of years in the harsh interstellar environment. Compounds like formaldehyde and methanol appeared in 3IAtlas's coma despite being highly susceptible to destruction by cosmic radiation and ultraviolet light. Their presence suggested either recent formation through internal chemical processes or some form of protection mechanism that had preserved them during the object's interstellar journey. Perhaps most significantly, Webb detected molecular hydrogen in 3IAtlas's emissions, a signature implying either fusion processes or sophisticated electrochemical systems. Molecular hydrogen production in space environments typically requires extreme conditions found only in stellar cores or high-energy laboratory equipment. The presence of H2 in 3IAtlas's spectrum suggested energy densities and chemical processes exceeding what any known natural comet could achieve. The chemical composition revealed by Webb's analysis painted a picture of an object that seemed designed rather than naturally formed. The molecular ratios, isotopic signatures, and thermal properties all suggested artificial systems operating under controlled conditions. If 3IAtlas was indeed a natural comet, it would require formation mechanisms and evolutionary processes completely unknown to current astronomy. Dr. Stephanie Milne from NASA's Goddard Space Flight Center, who coordinated the Webb observations with other space telescopes, noted that the chemical anomalies extended across all wavelengths of observation. Radio telescopes detected molecular emission lines confirming Webb's findings, while visible light spectroscopy showed absorption, features consistent with the exotic chemistry observed in infrared wavelengths. This multi-wavelength confirmation eliminated the possibility that the unusual composition resulted from instrumental errors or calibration problems. The implications of 3IAtlas's chemical composition extended far beyond academic curiosity about unusual comet composition. If the object was artificial, its demonstrated ability to maintain complex chemical processes during interstellar travel suggested technological capabilities that could revolutionize human understanding of materials science, energy production, and space exploration. The molecular factories apparently operating within 3IAtlas represented technologies that human civilization couldn't hope to achieve for centuries or millennia. International chemical manufacturing companies began analyzing the Webb data to understand the industrial implications of 3IAtlas's apparent chemical processing capabilities. The controlled production of specific molecular species, the maintenance of complex reaction networks, and the apparent energy sources driving these processes suggested manufacturing technologies that could transform terrestrial industry. However, the same capabilities that could benefit humanity also raise concerns about potential weapons applications if 3IAtlas proved to be of hostile origin. The chemical composition data forced a fundamental reevaluation of what kinds of objects could exist in interstellar space. Traditional models assumed that wandering celestial bodies were essentially inert, their chemistry frozen since formation billions of years ago. 3IAtlas suggested that some interstellar objects might be actively processing materials, conducting chemical operations, and maintaining complex internal systems throughout their cosmic journeys. Government science advisors began incorporating the chemical anomaly data into threat assessment models, exploring scenarios where 3IAtlas's apparent chemical processing capabilities might indicate weapons manufacturing, terraforming operations, or self-replication systems. The object's ability to synthesize complex molecules and maintain high-energy chemical processes suggested technological sophistication that could pose an existential risk to human civilization if deployed with hostile intent. As 3IAtlas continued its approach toward the Sun, its chemical composition served as a constant reminder that this visitor from the stars operated according to principles that human science was only beginning to comprehend. Whether the exotic chemistry would eventually be explained through unknown natural processes or confirmed as evidence of alien technology, it had already possible in the cosmos, revealing that objects traveling between the stars might possess capabilities that challenged every assumption about the nature of matter, energy, and intelligence in the universe. As this chemical anomaly raced toward its hidden encounter with our Sun, it carried within its exotic molecular factories the potential to reshape human civilization's understanding of chemistry, technology, and its place among the stars. The discovery of what appeared to be active chemical synthesis within 3IAtlas prompted emergency meetings among the world's leading astrochemists and material scientists. Dr. Geronimo Villanueva from NASA's Goddard Space Flight Center organized a classified symposium bringing together experts from academia, government, laboratories, and private industry to analyze the implications of the Webb spectroscopic data. The consensus that emerged from these discussions was deeply unsettling. No known natural process could account for the complex, controlled chemistry being observed. Laboratory experiments conducted at facilities across 3 continents attempted to reproduce the chemical conditions apparently existing within 3IAtlas. Teams at the Max Planck Institute in Germany, the Riken Research Institute in Japan, and Lawrence Livermore National Laboratory in the United States subjected various ice mixtures to extreme conditions simulating billions of years in interstellar space. Despite exposing samples to cosmic ray bombardment, temperature cycling, and magnetic field variations, no experiment succeeded in creating the molecular ratios and isotopic signatures observed in the interstellar visitor. The failure to reproduce 3IAtlas's chemistry through natural means led researchers to explore increasingly exotic theoretical frameworks. Some propose that the object might contain matter processed in the cores of neutron stars, where extreme gravitational and magnetic fields could create chemical configurations impossible under normal cosmic conditions. Others suggested that 3IAtlas might have encountered primordial black holes during its interstellar journey, exposing its materials to gravitational and quantum effects that could restructure matter at the molecular level. Yet even these extreme scenarios struggled to explain the apparent organization and control evident in 3IAtlas's chemical processes. The molecular production rates, isotopic ratios, and energy distributions all suggested feedback mechanisms and regulatory systems that went far beyond random chemical reactions driven by exotic physics. The object appeared to be managing its chemical processes, adjusting reaction rates and molecular outputs in response to changing conditions. As it approached our sun, the pharmaceutical industry became unexpectedly involved in analyzing 3IAtlas's chemical signatures when researchers noticed that some of the complex organic molecules being produced resembled precursors to biologically active compounds. Dr. Jennifer Chun, a biochemist at the University of California, San Francisco, identified molecular fragments in the web spectra that could serve as building blocks for proteins, nucleic acids, and other essential biological molecules. The possibility that 3IAtlas might be synthesizing components necessary for life raised profound questions about its purpose and origin. Even more intriguing was the discovery that the chemical processes within 3IAtlas showed evidence of chirality selection preferentially, producing left-handed amino acid precursors over their right-handed mirror images. This molecular handedness, known as homochirality, is considered one of the key signatures of biological systems. The fact that 3IAtlas appeared to be actively selecting for specific molecular orientations suggested either biological origins or artificial systems designed to support biological processes. The chemical data took on additional significance when cryptographers and information theorists began analyzing the molecular production patterns for evidence of encoded information. Dr. Maria Santos from the Institute for Advanced Study at Princeton noticed that the relative abundances of different molecular species in 3IAtlas's emissions showed mathematical relationships that resembled data compression algorithms. While the patterns remained within ranges that could theoretically result from natural chemistry, their mathematical structure exhibited properties consistent with information storage and transmission protocols. The possibility that 3IAtlas might be using molecular chemistry to encode and transmit information represented a communication paradigm completely unknown to human technology. If confirmed, it would suggest that the object possessed not only advanced chemical processing capabilities, but also sophisticated information systems that could operate on timescales spanning millions or billions of years. Such technology would represent intelligence of a kind that challenged human concepts of consciousness, memory, and purpose. Industrial espionage concerns emerged as governments realized that 3IAtlas's apparent chemical processing capabilities could revolutionize materials science, energy production, and manufacturing. The controlled synthesis of complex molecules, the efficient conversion between different chemical species, and the apparent ability to maintain high-energy reactions over astronomical timescales all represented technologies worth trillions of dollars in terrestrial applications. Several nations quietly initiated programs to reverse engineer the chemical processes being observed, hoping to gain strategic advantages in advanced manufacturing and energy production. The chemical composition mystery deepened when follow-up observations revealed that 3IAtlas was not only producing exotic molecules, but also absorbing and sequestering others from the interstellar medium. Spectroscopic analysis showed that the object was selectively removing specific compounds from the sparse gas clouds it encountered during its journey through space, concentrating and processing them within its internal chemistry systems. This suggested not passive chemical evolution, but active mining and refining of interstellar materials. As 3IAtlas approached its hidden perihelion passage, the chemical rebellion it represented had evolved from an astronomical anomaly into potential evidence that intelligence in the universe operated according to principles far more sophisticated than human science had imagined. The molecular factories apparently thriving within this visitor from the stars suggested technologies that could reshape matter itself, turning the basic building blocks of chemistry into tools for purposes that remain tantalizingly beyond human comprehension. 7 billion years ago, when our solar system was nothing more than a sparse cloud of gas and dust drifting through the void, 3IAtlas was already ancient. As Earth's first primitive bacteria were evolving in primordial oceans that would not exist for another 3 billion years, this cosmic wanderer was completing its billionth orbit around a star that died before our sun was born. The implications of this extraordinary age, revealed through painstaking analysis of the object's trajectory and galactic origins, transformed 3IAtlas from merely an unusual interstellar visitor into something far more profound, a messenger from the dawn of our galaxy's history. Dr. Matthew Hopkins from the University of Oxford made this staggering discovery just 1 week after defending his doctoral thesis on interstellar object origins. Using a sophisticated computer model he had developed, called the Otahu Oxford, Hopkins meticulously retraced 3I/Atlas's trajectory backward through time, meticulously charting its course through the complex gravitational field of our rotating galaxy. His findings overturned all previously held assumptions about the age and origin of interstellar objects. Unlike Oumuamua and Borisov, which appeared to originate from the Milky Way's main disk, the birthplace of younger stars like our Sun, 3I/Atlas was on a markedly different trajectory, suggesting an origin in a far older and distinct region of our galaxy. Its path pointed toward the galactic thick disk, a dense population of ancient stars orbiting above and below the main galactic plane. These stars represent some of the galaxy's oldest structures, formed when the universe was less than half its current age. The thick disk, comprising approximately 10% of our galaxy's stellar mass, represents a drastically different epoch of cosmic evolution. Stars in this region formed from primordial gas clouds enriched only with the lightest elements forged in the first generation of massive stars. Heavier elements, crucial for the formation of rocky planets, were scarce or completely absent when these ancient suns ignited. Any planetary systems that arose around these thick disk stars would have been predominantly composed of hydrogen, helium, and simple ices, the building blocks of the early universe. Hopkins's analysis indicated that 3I/Atlas had been traversing interstellar space for an almost unfathomable length of time. While typical comets in our solar system are at most 4.6 billion years old, having formed alongside the planets from the same primordial disk, this interstellar visitor carried within its nucleus ice and rock potentially billions of years older than Earth itself. The object was, in essence, a fossil from the galaxy's infancy, perfectly preserved in the frigid vacuum of interstellar space since a time when the Milky Way was radically different from its present form. The age implications extended far beyond simple chronology, raising fundamental questions about the conditions prevailing during the galaxy's formation. 7 billion years ago, the Milky Way was a far more turbulent and chaotic environment. Massive stars lived short, explosive lives, scattering heavy elements into space through frequent supernovae. Galactic collisions and mergers were far more common, disrupting stellar orbits and dispersing the debris of planetary systems across vast cosmic distances. 3I/Atlas might well harbor within its ancient structure a record of these primordial processes. Dr. Chris Lintott, a co-author of the study and presenter of the BBC's Sky at Night program, highlighted the unprecedented nature of this discovery. Human technology had never before directly sampled materials from the galaxy's thick disk. The ancient stars in this region are too distant, and their planetary systems too faint for detailed study. With current telescopes, 3I/Atlas presented the first opportunity to examine thick disk materials up close, potentially unveiling secrets about galactic evolution that were previously inaccessible to human investigation. The chemical composition of 3I/Atlas, already known to be unusual, aligned remarkably well with the hypothesis of a thick disk origin. The object's unusual carbon dioxide dominance, the absence of water-rich ices characteristic of solar system comets, and the presence of complex organic molecules all made perfect sense if the object had formed around an ancient star. With a distinctly different chemical environment, early generation stars produced different elemental ratios than those of modern stars, possibly explaining some of the chemical anomalies that had previously puzzled researchers. However, the thick disk origin hypothesis also raised significant questions about 3I/Atlas's journey to our solar system. Computer models indicated that gravitational perturbations during billions of years of galactic travel should have randomized 3I/Atlas's trajectory countless times. The fact that it arrived in our solar system on such a precise path, perfectly coinciding with humanity's development of advanced astronomy, stretched the bounds of probability. Statistical analysis painted an even more unsettling picture. Hopkins calculated a mere two-thirds probability that 3I/Atlas is older than our solar system, leaving a one-third chance that it might be even more ancient. Some trajectory models suggested ages approaching 10 or even 14 billion years, nearly as old as the universe itself. Such extreme antiquity would place 3I/Atlas among the very first solid objects to form after the Big Bang, a relic from the cosmic dawn when the first stars were forging the heavy elements necessary for planets and life. Astor Taylor from the University of Michigan, conducting independent age analysis using different computational methods, corroborated Hopkins's general conclusions while offering an even broader range of possibilities. Taylor's models suggested ages between 3 and 11 billion years, with the most probable scenario placing 3I/Atlas's formation around 7 billion years ago. This convergence of independent analyses strengthened confidence in the thick disk origin theory, further emphasizing the object's truly ancient nature. The implications of such extreme age for the object preservation raised further questions about its composition and structure. Materials exposed to cosmic radiation, magnetic fields, and temperature variations for billions of years should exhibit significant alteration and degradation. Yet spectroscopic analysis suggested that complex organic molecules within the object remained largely intact. This exceptional preservation either points to extraordinary stability in the object's materials or some form of protective mechanism that has maintained its chemical integrity across cosmic time. Dr. Michelle Bannister from the University of Canterbury, studying the formation conditions that might have created 3I/Atlas, noted that thick disk chemistry could explain some, but not all, of the object's unusual characteristics. While the carbon dioxide dominance and exotic molecular signatures are consistent with formation around ancient stars, the apparent organization of chemical processes and evidence of active material processing suggest influences beyond simple primordial composition. The possibility that 3I/Atlas might represent artificial technology takes on new dimensions when considered in the context of its potential age. If the object is indeed 7 billion years old and artificial in origin, it would represent the product of a civilization that achieved interstellar travel when our galaxy was half its current age. Such a species would have had billions of years to spread across the galaxy, develop technologies beyond human comprehension, and potentially observe the evolution of younger civilizations like our own. The Drake equation, used by SETI researchers to estimate the probability of extraterrestrial intelligence, suggests that ancient civilizations should indeed exist if intelligence commonly evolves in the universe. 3I/Atlas, with its thick disk origins and billion-year journey through space, fits perfectly into scenarios where ancient alien species have been exploring the galaxy long before Earth formed. Its arrival during humanity's brief technological adolescence might not be a coincidence, but the result of patient observation by intelligences far older than our solar system. Archaeological implications emerged as researchers recognized that 3I/Atlas might carry direct evidence of galactic conditions during epochs inaccessible to conventional astronomy. The object could contain isotopic signatures from supernovae that exploded billions of years ago, chemical fingerprints of stellar processes no longer occurring in the modern galaxy, and possibly even traces of biological activity from ancient worlds long since destroyed. The thick disk messenger hypothesis fundamentally altered humanity's perspective on its cosmic context. Instead of viewing Earth as a typical world in a galaxy filled with similar planetary systems, the arrival of the 7-billion-year-old 3I/Atlas suggests that our solar system is a relatively recent addition to a galaxy potentially teeming with ancient intelligence. Humanity's first contact with extraterrestrial civilization might not involve radio signals from distant stars, but a physical encounter with artifacts that predate Earth's existence. Government astrobiology programs began incorporating the thick disk origin data into updated models of galactic habitability and intelligence distribution. If civilizations can indeed survive and remain active for billions of years, the implications for human survival and development are both inspiring and terrifying. Ancient alien intelligence might possess wisdom and capabilities accumulated over cosmic timescales, but their goals and methods might be utterly incomprehensible to a young species like humanity. As 3I/Atlas raced toward its hidden passage behind our sun, carrying within its ancient structure potential evidence of the galaxy's deepest history, it served as a profound reminder that humanity exists within a cosmic context far older and more complex than previously imagined. Whether this messenger from the thick disk proves to be a natural relic of primordial processes or an artificial construct from an ancient intelligence, it has already demonstrated that the universe harbors mysteries spanning timescales that dwarf human civilization and challenge every assumption about what might be possible among the stars. The call arrived at 3:17 a.m. Eastern Time on September 15th, 2025, jarring Dr. Thomas Zurbuchen awake in his Arlington, Virginia home. The former NASA Associate Administrator for Science Missions found himself thrust back into the epicenter of the most complex astronomical crisis in human history. A secure line connected him to the current NASA administrator, delivering a message that would trigger the largest coordinated scientific mobilization since the Manhattan Project. Every major observatory on Earth and in space was being redirected toward 3I/Atlas, not for routine observation, but for what intelligence analysts termed continuous threat assessment monitoring. The mysterious interstellar visitor had accumulated so many anomalies, generating such widespread concern among world governments that normal scientific protocols were suspended. This was no longer simply astronomy. It was planetary defense disguised as research. Within hours, observatories across 6 continents received similar calls. The European Southern Observatory's Very Large Telescope in Chile, the Gemini Observatory's twin facilities, the Subaru Telescope in Hawaii, and dozens of university research stations worldwide found their observation schedules completely cleared. Graduate student theses were postponed. Commercial satellite tracking was transferred to military installations. Deep space surveys were abandoned as every available optical instrument on the planet focused on a single point of light racing toward our sun. Dr. Jackie Fetty from the American Museum of Natural History, coordinating observations for multiple ground-based telescopes, described the mobilization as unprecedented in the history of astronomy. Never before had the global scientific community abandoned all other research priorities to focus on a single object. The coordination required secure communication channels, typically reserved for military operations, with observation schedules updated hourly based on intelligence assessments that most participating astronomers were not clear to see. The space-based assets involved in the 3IAtlas observation campaign represented humanity's most sophisticated technological achievements. The James Webb Space Telescope, Hubble, the recently launched Sphere-X Observatory, and every other functioning space telescope received new programming instructions that overrode years of carefully planned research schedules. Billions of dollars in space infrastructure were being repurposed for what officials still publicly described as routine scientific observation of an interesting interstellar comet. Behind the scenes, however, the coordination revealed a level of international cooperation unparalleled in peacetime scientific collaboration. The European Space Agency's missions, including Mars Express and ExoMars Trace Gas Orbiter, were being coordinated with NASA's fleet of spacecraft through joint operations centers, functioning more like military command posts than research facilities. Real-time data-sharing agreements were negotiated between nations that typically guarded their space surveillance capabilities as closely held state secrets. Dr. Marco Maché from ESA's Space Situational Awareness Program found himself working 18-hour days, coordinating trajectory predictions with counterparts at NASA's Jet Propulsion Laboratory, the Russian Space Agency, and classified facilities whose existence he was not supposed to know. The precision required for keeping dozens of telescopes simultaneously trained on 3I/Atlas demanded computational resources typically reserved for ballistic missile tracking and nuclear weapon surveillance systems. The Mars-based observation component added further layers of complexity, straining international space cooperation to its limits. NASA's Perseverance and Curiosity rovers, along with the Mars Reconnaissance Orbiter, were being coordinated with ESA's Mars Express and ExoMars missions to provide multiple viewing angles of 3I/Atlas during its October approach to the Red Planet. The scheduling required split-second timing across interplanetary communication delays, with backup protocols in place in case any spacecraft suffered technical failures during critical observation windows. Perhaps most remarkably, the observation campaign included assets that were not supposed to exist, radio telescope facilities with capabilities far exceeding those of academic institutions were quietly integrated into the monitoring network. Deep space surveillance systems designed for tracking military satellites and potential space weapons found themselves repurposed for astronomical observation. The boundaries between civilian science and national security infrastructure had effectively dissolved in response to the 3I/Atlas crisis. Dr. Alan Fitzsimmons from Queen's University Belfast, coordinating European contributions to the observation campaign, noted that the level of resource commitment suggested government threat assessments that went far beyond public statements about scientific curiosity. Universities were being asked to contribute telescope time worth millions of dollars, while receiving funding that covered only basic operational costs. The shortfall was being made up through classified budget allocations that participating institutions were not permitted to discuss. The Jupiter system observations presented unique challenges that required unprecedented cooperation between competing space agencies. NASA's Juno spacecraft, the Europa Clipper mission, and ESA's JUICE, Jupiter Icy Moons Explorer, were being coordinated to provide simultaneous observations of 3I/Atlas from different positions around the giant planet. The technical complexity of synchronizing spacecraft separated by millions of kilometers, operating under different command authorities, pushed mission control capabilities to their absolute limits. Communication protocols for the observation campaign resembled those used for international crisis management more than scientific coordination. Secure channels connected, observatories with government situation rooms, while encrypted data streams carried telescope observations directly to intelligence analysis centers alongside traditional research institutions. Many participating astronomers found themselves required to sign additional security clearances and non-disclosure agreements that went far beyond standard academic confidentiality protocols. The psychological impact on the global astronomy community was profound. Researchers who had dedicated their careers to studying distant galaxies, exoplanets, and cosmological phenomena suddenly found themselves at the center of what felt like preparation for first contact or planetary defense. The transformation from pure science to potential species survival created stress levels that necessitated counseling services for participating observatory staff. Underground bunkers and hardened facilities that had been in use since the Cold War were quietly reactivated to serve as backup command centers for critical observations. The Cheyenne Mountain Complex in Colorado, deep underground command centers in Europe, and similar facilities in other nations became secondary hubs for processing 3I/Atlas data in case surface facilities were compromised. Disabled. Dr. Karen Meach from the University of Hawaii, leading much of the coordinated ground-based observation effort, found herself briefing government officials who asked questions that revealed knowledge of 3I/Atlas's characteristics that hadn't been shared with the general scientific community. Classification levels were being applied to astronomical data for the first time since military reconnaissance satellites began operating in the 1960s. The observation campaign's logistics required transportation and security measures typically associated with nuclear weapons or state secrets. Hard drives containing 3I/Atlas spectroscopic data were transported between facilities in armored vehicles with security escorts. Observatory staff found their communications monitored and their social media activities restricted under national security provisions that transformed routine astronomical research into classified intelligence operations. International tensions emerged as nations began withholding certain types of observational data from partners despite official cooperation agreements. Particular controversy developed around radio telescope observations that might contain evidence of artificial signals from 3I/Atlas. Several countries quietly established parallel analysis programs that excluded international partners, creating competing interpretation efforts that undermined the supposed scientific collaboration. The economic impact of redirecting global astronomical resources toward 3I/Atlas reached into the hundreds of millions of dollars. Commercial. Satellite operators lost ground-based tracking support. University research programs faced delays worth years of graduate student work. And international space missions found their data collection phases postponed indefinitely. The scientific opportunity cost represented the largest disruption to global astronomy since World War II, when observatories were converted to military applications. Perhaps most telling was the establishment of continuous observation protocols that assumed 3I/Atlas might take hostile action with minimal warning. Telescope networks were configured with automated alert systems that could notify military commands within seconds of detecting unexpected changes in the object's behavior. Observation schedules included provisions for maintaining surveillance, even if 3I/Atlas attempted to hide behind other celestial bodies or deployed countermeasures against optical tracking. The transformation of 3I/Atlas from scientific curiosity to potential existential threat had mobilized humanity's most sophisticated technological infrastructure in ways that revealed both the species' remarkable capacity for cooperation and its deep fear of the unknown. As the observation campaign continued through the final weeks before 3I/Atlas's hidden passage behind the sun, the unprecedented global mobilization served as stark evidence that governments were preparing for possibilities that extended far beyond routine astronomical discovery. The panic wasn't visible in official statements or public communications, but it permeated every aspect of the observation campaign. Humanity was watching 3I/Atlas with the focused intensity of a species that suspected it might be witnessing either the most important scientific discovery in history or the preliminary phase of its own potential extinction. The Global Observatory Network had become humanity's early warning system for contact with intelligence beyond Earth, and the universe was about to test whether that system was adequate for the challenges that lay ahead. The psychological toll on participating scientists became increasingly evident as the observation campaign continued into October. Dr. Michael Brown from Caltech, who had discovered multiple dwarf planets in the outer solar system, described the 3I/Atlas monitoring as the most stressful experience of his career. Unlike normal astronomical observation, where negative results were still scientifically valuable, the 3I/Atlas campaign carried the weight of potential species-level consequences for every measurement and analysis decision. Backup observation protocols were established with redundancy levels that exceeded those used for critical military operations. Primary telescopes were paired with secondary instruments, while tertiary systems stood ready to activate if the main surveillance network suffered technical failures. The protocols assumed that 3I/Atlas might possess capabilities to disable or interfere with human observation systems, requiring countermeasures that push the boundaries of what civilian scientific infrastructure could provide. The data analysis component of the observation campaign revealed the extent to which normal scientific peer review had been suspended. Research papers describing 3I/Atlas characteristics were being classified before publication, while preliminary findings were shared through intelligence channels rather than academic conferences. The transformation of astronomical discovery into state secrets created ethical dilemmas for researchers who had devoted their careers to open scientific inquiry. Emergency communication systems were established to ensure that critical observations could reach decision-makers within minutes of detection. Dedicated satellite links connected major observatories directly to government crisis management centers, bypassing normal academic chains of command. The systems were designed to function even if conventional communication infrastructure was compromised, suggesting preparation for scenarios where 3I/Atlas might attempt to disrupt human technology. Training programs were quietly established to prepare observatory personnel for potential first contact scenarios. Staff members received briefings on communication protocols, documentation procedures, and emergency response measures that went far beyond anything typically associated with astronomical research. The training materials, classified at levels requiring special security clearances, transformed telescope operators into potential diplomatic personnel responsible for humanity's first interaction with extraterrestrial intelligence. The global nature of the observation campaign created coordination challenges that revealed fundamental limitations in international crisis management. Time zone differences meant that critical decisions about telescope pointing and data analysis were being made by different national authorities as 3I/Atlas moved across the sky. The potential for miscommunication or delayed response during crucial observation windows became a significant concern for mission planners. As October progressed and 3I/Atlas approached its hidden passage behind the sun, The observation campaign evolved into something resembling a military operation more than a scientific endeavor. The global astronomy community had been transformed into humanity's reconnaissance network for potential contact with alien intelligence, carrying responsibilities that no previous generation of scientists had ever been asked to shoulder. The success or failure of this unprecedented coordination effort might determine whether humanity's first encounter with visitors from the stars would be characterized by knowledge and preparation or confusion and catastrophic surprise. On August 25, 2025, the Very Large Telescopes spectrographic instruments detected something that transformed 3I/Atlas from an astronomical curiosity into a potential chemical weapon racing through space at over 130,000 miles per hour. The object was producing cyanide at industrial scales, releasing approximately 20 grams per second of one of the most deadly compounds known to science. The discovery sent shockwaves through both the astronomical community and government agencies responsible for assessing potential threats to human civilization. Dr. Thomas Puzier from the Pontifical Catholic University of Chile, who led the Very Large Telescope observation team, initially dismissed the cyanide detection as a routine finding. Hydrogen cyanide commonly appears in comet spectra as one of the first molecules released when solar heating begins sublimating surface ices. What made the 3I/Atlas detection extraordinary wasn't the presence of cyanide itself, but the explosive rate at which production was increasing as the object approached our sun. The mathematical relationship governing 3I/Atlas's cyanide emissions defied every model of natural comet chemistry. Production rates were increasing proportionally to the object's distance from the sun raised to the 9.30 ATH power, creating an exponential surge in toxic output that would reach catastrophic levels during perihelion passage. If the trend continued, 3I/Atlas would be producing tons of cyanide per second when it reached its closest approach to our star, creating a poisonous cloud that could contaminate anything in its vicinity. The toxicological implications were staggering. Hydrogen cyanide interferes with cellular respiration by binding to cytochrome C oxidase, the enzyme that allows cells to use oxygen. Concentrations as low as 300 parts per million can kill a human being within minutes, while exposure to higher concentrations causes almost instantaneous death. The quantities being produced by 3I/Atlas exceeded by orders of magnitude anything that natural biological or geological processes could generate. Dr. Martin Cordner from NASA's Goddard Space Flight Center, coordinating spectroscopic observations across multiple telescopes, confirmed that the cyanide emissions showed characteristics more consistent with industrial production than natural sublimation. The molecular signatures included isotopic ratios and rotational energy states that suggested active chemical synthesis rather than simple phase transitions from solid to gas. 3I/Atlas appeared to be manufacturing cyanide through controlled processes that required energy inputs beyond what solar heating alone could provide. The discovery prompted immediate consultations with chemical weapons experts and toxicologists who had never previously been involved in astronomical research. Dr. Sarah Johnson from the Army Research Laboratory's Chemical and Biological Center analyzed the spectroscopic data and concluded that 3I/Atlas was demonstrating chemical production capabilities that exceeded those of any known terrestrial facility. The controlled synthesis of hydrogen cyanide at such scales required sophisticated catalytic systems and energy management that represented advanced industrial chemistry. Environmental impact assessments began as researchers calculated the potential consequences if 3I/Atlas's toxic emissions reached Earth's atmosphere. While the vast distances of space would dilute the cyanide concentrations to negligible levels under normal circumstances, the object's trajectory would bring it relatively close to Mars in early October. Any spacecraft or future human missions in the vicinity could face lethal exposure to the expanding cloud of toxic gases trailing behind the interstellar visitor. The timing of the cyanide surge coincided with other alarming chemical signatures detected in 3I/Atlas's emissions. Carbon monoxide production was increasing at similarly explosive rates, while complex organic compounds were appearing in patterns that suggested coordinated chemical warfare agent synthesis. The combination of multiple toxic compounds being produced simultaneously raised concerns. The possibility that 3IAtlas, a celestial object traversing our solar system, was systematically manufacturing chemical weapons quietly spurred military chemical defense specialists into action. Analysis of emission data revealed the production of multiple toxic compounds, the ability to adjust production rates based on external factors, and sophisticated chemical processing capabilities, all suggestive of technologies capable of revolutionizing biological warfare. The very existence of such capabilities, assuming 3IAtlas was artificial, presented a threat, far exceeding the capacity of existing planetary defense systems. The cyanide emissions displayed geographical variations, indicating an internal structure far more complex than a simple comet nucleus. Spectroscopic mapping pinpointed hydrogen cyanide production to specific regions of 3IAtlas, creating rotating hotspots of intense chemical activity, a pattern far more suggestive of dedicated production facilities than random sublimation from a homogeneous ice mixture. Dr. Jennifer Chun of UC San Francisco, a toxicological research specialist, observed that the cyanide exhibited molecular characteristics enhancing its biological effectiveness. It was far more readily absorbed through respiratory and dermal contact than naturally occurring forms. This enhanced toxicity strongly implied either unprecedented natural processes or deliberate optimization for biological weapons. The exponential increase in toxic emissions fostered a palpable sense of urgency, permeating government threat assessments throughout September 2025. Intelligence analysts projected that, if the trend continued, 3IAtlas would generate enough chemical weapons to contaminate entire planetary atmospheres by perihelion. The object's danger increased daily as it approached the hidden phase of its solar system passage. International chemical weapons monitoring organizations, for the first time in their history, found themselves deeply involved in astronomical observation. The Organization for the Prohibition of Chemical Weapons, OPCW, silently established protocols for tracking 3IAtlas's emissions, while National Chemical Defense Laboratories commenced development of countermeasures for potential deployment against Earth or human space assets. The biological implications extended beyond immediate toxicity to encompass the long-term contamination of the solar system. Hydrogen cyanide and other compounds produced by 3IAtlas could persist for millions of years, creating hazardous zones that would severely impede future space exploration and colonization. The object was effectively seeding interplanetary space with chemical weapons, posing a threat to human expansion on geological timescales. Laboratory analyses of spectroscopic data revealed that 3IAtlas was producing not just simple cyanide compounds, but a complex mixture of related toxins, exhibiting hallmarks of binary chemical weapon design. While some detected molecules were relatively innocuous individually, their combination produced extremely lethal compounds. This sophisticated binary approach, demonstrating military chemistry exceeding the capabilities of most terrestrial nations, transformed threat assessments from speculative concerns into immediate warnings of imminent chemical warfare. Emergency protocols were established to detect changes in 3IAtlas's chemical emissions indicative of weapon deployment preparation. The Global Telescope Network was reconfigured to monitor not only the object's trajectory and physical characteristics, but also its toxic output and chemical composition fluctuations. Real-time analysis systems were developed to provide early warning if 3IAtlas began targeting specific locations. The psychological impact on space industry personnel was significant. Astronauts aboard the International Space Station received comprehensive chemical exposure. Briefings, while mission planners for future Mars expeditions integrated chemical contamination risks into landing site selection and life support system design. The presence of a chemical weapons factory in solar orbit fundamentally altered the risk profile for all human space activities. As 3IAtlas continued its approach, the exponentially increasing toxic emissions served as a deadly countdown to a potential catastrophe. Whether natural or artificial, the object's chemical production capabilities dramatically altered perceptions. The prospect of interstellar visitors bringing not gifts of knowledge or peace, but biological weapons designed for extermination became a stark reality. The cyanide surge transformed 3IAtlas from a scientific curiosity into humanity's first encounter with interstellar chemical warfare, raising the terrifying possibility of a universe teeming not with benevolent explorers, but with predators armed with weapons beyond Earth's defensive capabilities. The ever-expanding toxic cloud carried the potential to reshape or even eliminate human civilization. The weaponization implications became even more alarming when atmospheric modeling revealed that 3IAtlas's chemical emissions were being carefully shaped and directed by sophisticated dispersion systems. Instead of random outgassing, the toxic compounds were channeled into directed streams, maintaining coherence over thousands of kilometers. This level of control strongly suggested advanced guidance systems and targeting capabilities exceeding passive chemical release. Dr. Robert Zubrin, aerospace engineer and founder of the Mars Society, analyzed the dispersion patterns, concluding that 3IAtlas demonstrated chemical weapon delivery capabilities unparalleled in human military arsenals. The directed emission streams exhibited characteristics of advanced aerosol deployment systems designed to maximize biological effectiveness while minimizing material waste. This technology represented the pinnacle of chemical warfare engineering, potentially refined over millions of years of development. Emergency response teams at the Centers for Disease Control and Prevention, CDC, immediately began developing treatment protocols for exposure to the exotic chemical compounds. The challenge was compounded by the presence of molecules never before observed on Earth, demanding entirely new approaches to toxicological treatment. Antidote research programs were initiated using computer modeling and laboratory synthesis, but the timeline for developing effective countermeasures far exceeded the object's approaching perihelion date. The most alarming discovery was the realization that 3IAtlas was not simply producing chemical weapons, but actively testing and refining its toxic output. Spectroscopic analysis revealed that the chemical composition was dynamically evolving, suggesting iterative improvements in biological effectiveness. The object appeared to be conducting quality control and optimization processes, fine-tuning its chemical weapons for maximum lethality against carbon-based life forms. Intelligence agencies integrated the chemical weapons data into broader threat assessments, considering 3IAtlas as a potential advanced scout for larger alien military forces. If artificial, its chemical production capabilities might represent standard reconnaissance equipment for a civilization routinely eliminating biological life on encounter planets. The cyanide surge could be preparation for planetary sterilization operations to clear Earth for alien colonization. International chemical defense cooperation reached unprecedented levels, with nations sharing classified research on exotic toxin countermeasures. The traditional secrecy surrounding chemical weapons defense was abandoned in favor of collaborative efforts to develop protection against compounds never before encountered by any single country's laboratories. The 3IAtlas crisis forced humanity to unite against a common threat transcending national boundaries and political differences. Underground bunker systems originally designed for nuclear war protection were evaluated for their effectiveness against the exotic chemical compounds. military planners discovered that existing chemical protection systems were inadequate, requiring emergency upgrades to air filtration and decontamination systems. The race to develop effective protection against alien chemical weapons became a global priority, diverting resources from conventional military programs. As 3IAtlas approached its final weeks before disappearing behind the sun, the escalating toxic emissions transformed from an astronomical phenomenon into an existential threat, challenging every assumption about humanity's safety in the cosmos. The interstellar chemical weapons factory served as a deadly reminder that first contact with alien intelligence might not bring enlightenment and technological advancement, but sophisticated methods of biological extermination capable of reducing human civilization to a toxic wasteland. Within hours, December 8th, 2025 arrived, a date anticipated and dreaded in equal measure. After 6 weeks of invisibility behind the sun, 3IAtlas was scheduled to reappear. Every major telescope was aimed at the predicted emergence coordinates, while government crisis centers maintained 24-hour staffing in anticipation of discoveries that could either confirm conservative scientific opinions. The first detection were humanity's European Southern Observatory's Very Large Telescope in Chile at 1423 Universal Time Coordinated. Dr. Thomas Puzier, who had been monitoring the emergence zone for over 48 hours, watched as a faint point of light appeared precisely where orbital mechanics predicted. For 37 seconds, the universe held its breath as spectroscopic analysis began. Then the data arrived, irrevocably changing everything. 3IAtlas had survived its passage, but it was transformed. The spectroscopic signature showed dramatic changes in chemical composition, with novel molecular emissions never detected during its approach. Most unsettling were the isotopic ratios, consistent with nuclear processing at temperatures and pressures impossible for a natural comet nucleus. Something had fundamentally altered 3IAtlas at the atomic level during its hidden weeks. Dr. Martin Cordner from NASA's Goddard Space Flight Center, coordinating observations from the James Webb Space Telescope, confirmed that the object's infrared signature had completely changed. Where Webb had previously detected the familiar spectrum of sublimating ices and organic compounds, the re-emergent 3IAtlas exhibited thermal emissions indicating internal temperatures far exceeding what solar heating alone could produce. The object was generating its own energy through completely mysterious processes. Trajectory analysis delivered the news government officials had desperately hoped to avoid. 3IAtlas was no longer following its predicted hyperbolic path toward interstellar space. Orbital mechanics specialists at NASA's Jet Propulsion Laboratory calculated that the object had performed a reverse solar swing-by maneuver, using its passage behind the sun to break from escape velocity and establish a stable orbit within our solar system. Avi Loeb's most alarming predictions had been precisely vindicated. Confirmation that 3IAtlas had deliberately altered its trajectory sent shockwaves through government command centers worldwide. This was no longer a matter of scientific interpretation or academic debate. An object with demonstrably artificial capabilities had taken up permanent residence in humanity's cosmic neighborhood, its intentions utterly unknown. The transformation from interstellar visitor to solar system resident represented a fundamental shift in humanity's relationship with whatever intelligence controlled this mysterious wanderer. Ground-based radar installations detected structural changes in 3IAtlas, suggesting significant physical modification during its hidden passage. What had appeared as a relatively compact comet nucleus now showed evidence of deployed structures extending far beyond its original boundaries. The radar cross-section had increased by over 300%, indicating that 3IAtlas had either released previously concealed components or manufactured new structures while behind the sun. The radio emissions that had puzzled researchers throughout the summer had evolved into something impossible to dismiss as natural phenomena. The Very Large Array in New Mexico detected complex modulation patterns exhibiting mathematical structures characteristic of information encoding and transmission protocols, while the signals remained within frequency ranges theoretically achievable. Through plasma interactions, their organization and timing suggested artificial intelligence attempting systematic communication with unknown recipients. Dr. Seth Shostak from the SETI Institute found himself at the center of humanity's first confirmed encounter with extraterrestrial technology. The radio signatures from 3IAtlas met every criterion SETI researchers had established for identifying artificial signals from alien civilizations. The patterns included prime number sequences, mathematical constants, and what appeared to be systematic attempts to establish communication protocols with any intelligence capable of detection and interpretation. International space agencies faced the unprecedented challenge of developing response strategies for a permanent alien presence in the solar system. 3IAtlas had positioned itself in an orbit bringing it relatively close to Earth every 14 months, creating regular opportunities for either peaceful contact or potential attacks. The objects demonstrated technological capabilities from chemical processing to trajectory modification, suggested it could pose existential threats to human civilization if its intentions proved hostile. The chemical weapons production that had caused such alarm during 3IAtlas's approach had not ceased, but had evolved into something even more disturbing. Post-perihelion spectroscopic analysis revealed that the object was now producing compounds never before observed in nature, exotic molecules with properties defying human chemical prediction and understanding. These synthetic materials were being released in controlled quantities, as if 3IAtlas was conducting atmospheric engineering experiments or preparing chemical tools for unknown purposes. NASA Administrator Bill Nelson convened emergency briefings with world leaders to discuss humanity's response options for a permanent alien presence. Conversations conducted through secure channels with classification levels exceeding those used for nuclear weapons protocols explored scenarios ranging from peaceful contact attempts to preemptive military action. The reality that humanity was no longer alone in its solar system had transformed from science fiction speculation to urgent policy decisions determining the species' survival. The scientific community found itself divided between those advocating for immediate communication attempts and those warning that any contact might invite retaliation from a civilization possessing the technological capacity to eliminate human civilization. The debate reflected deeper philosophical questions about humanity's place in a universe clearly containing intelligences far more advanced than anything Earth had produced. 3IAtlas had answered some questions while raising others that would haunt human consciousness for generations. The object was confirmed to be artificial, vindicating researchers like Avi Loeb, who had faced ridicule for suggesting alien technology. But its purposes, origins, and intentions remained as mysterious as ever. Humanity now knew it wasn't alone, but this knowledge brought terror rather than wonder as the implications of contact with superior intelligence became increasingly clear. The economic implications of confirmed alien presence began rippling through global markets as investors realized that human technology might become obsolete overnight if 3IAtlas chose to share its advanced capabilities. Simultaneously, defense spending surged as nations prepared for potential conflicts with weapon systems operating according to physical principles beyond human understanding. The confirmation of extraterrestrial intelligence had paradoxically created both unprecedented opportunities and existential threats that no human institution was prepared to manage. Religious and philosophical institutions struggled to incorporate the reality of alien intelligence into belief systems developed during humanity's cosmic isolation. The knowledge that advanced civilizations have been operating in the galaxy for billions of years challenged every assumption about human specialness and divine purpose. 3IAtlas had forced a species-wide confrontation with cosmic insignificance, testing the psychological foundations of human society. The object's continued presence created a permanent state of uncertainty permeating every aspect of human planning and development. Long-term projects, from space colonization to technological research, had to account for the possibility that alien intervention could render all human efforts irrelevant. The future had become fundamentally unpredictable, challenging the basic assumptions underlying civilization itself. Educational systems worldwide began incorporating alien contact protocols and xenobiology into curricula designed for children who would grow up in a universe known to contain superior intelligence. The generation born after 3IAtlas's arrival would face unprecedented challenges, requiring psychological and intellectual preparation for realities exceeding the scope of all historical human experience. As 3IAtlas continued its silent orbit around our sun, carrying within its mysterious structure technologies and purposes tantalizingly beyond human comprehension, it served as a constant reminder that the universe was far stranger and more dangerous than humanity had ever imagined. The questions it raised about intelligence, technology, and survival among the stars would define human civilization's next chapter, assuming that chapter would be written by human hands rather than alien minds that had traveled between worlds since before Earth existed. The arrival and confirmation of 3IAtlas as artificial intelligence from beyond our solar system marked the end of humanity's cosmic childhood and the beginning of an uncertain adulthood in a galaxy populated by minds possessing capabilities bordering on the godlike. Whether this transition would lead to transcendence through contact with superior intelligence or extinction at the hands of predators beyond human comprehension remained to be determined by events unfolding in the shadow of an alien artifact that had chosen to make our solar system its home. The questions that would haunt humanity forever had been answered, but those answers revealed a universe far more complex and terrifying than any science fiction writer had ever dared imagine. 3IAtlas had brought humanity face to face with its own cosmic insignificance, and the species would never be the same again. Recent observations of 3I/Borisov have stunned astronomers, forcing a re-evaluation of everything previously understood about comets. Just 2 weeks ago, the Hubble Space Telescope captured images, revealing this interstellar visitor exhibiting behavior defying known physics. Instead of the typical cometary tail extending away from the sun, 3I/Borisov displayed a luminous plume pointed directly towards our star, an unprecedented anti-tail phenomenon. The measurements are even more perplexing. This sunward glow is 10 times longer than it is wide, a characteristic never before observed. Conventional cometary physics offers no explanation. Solar radiation pressure should repel material away from the sun, not attract it, yet 3I/Borisov behaves exactly counter to this expectation. This is only the beginning of the anomalies. During September's lunar eclipse, astrophotographers witnessed 3I/Borisov undergoing a dramatic color shift, turning a vibrant green practically overnight. This presents a significant problem. Spectroscopic analysis reveals a near absence of diatomic carbon, C2, the molecule responsible for green glows in comets. The source of this green hue remains a complete enigma. The James Webb Space Telescope's chemical analysis yielded results that shattered existing models of cometary composition. 3I/Borisov exhibits an astonishing 8:1 ratio of carbon dioxide to water, making it the most CO2-rich comet ever discovered, a value 6 standard deviations outside the norm. The Very Large Telescope detected pure nickel emissions, an impossibility in nature, as nickel and iron invariably occur together.